Okay, angle measures an opening. How open is my door, right? This is a small angle. This angle is like 10, right? This is like 90 degrees, right? Same thing here. Anything less than 90 is called an acute angle. Right angle is exactly 90. Obtuse is bigger than 90, but not over 180. Straight angle is 180, exactly 180, okay? A reflex angle is bigger than 180. A full rotation is 360. So straight angle is a half turn. A full turn is 360. A half turn is 180. So it's like you guys, I'm facing you guys right now. If I wanted to do a 180 turn, I would face the complete opposite direction, right? You can see the back of my head. 360 means you make a full turn and I'm back to where I started. That's the difference, okay? That's the difference between. And then a quarter turn. Half turn is a 180, right? A quarter turn is a right angle. 90 degrees, 90 degrees, 90 degrees, 90 degrees, right? So half turn or a half rotation is a 180. A quarter rotation is 90, okay? So starting today, you're going to see some negative angles. We've only seen positive angles. Why are there negative angles? Direction. Which direction are you going? If you go, we call it counterclockwise. The way my finger is going right now is counterclockwise, opposite of a clock. So a clock, if you were to speed up a clock, it would go like this. The hands would go like this, in this direction. Positive angles go the opposite. They go counterclockwise. They go in this direction, okay? So that's a positive. That's a positive direction. Opposite is negative direction, okay? So if I'm going like a clock, if I'm moving like a clock, those are negative angles. So the negative angle is getting bigger and bigger and bigger, okay? That's the only difference. So down here, I give you some examples of positive angles and negative angles. So the positive angles are all moving counterclockwise. Opposite of a clock. Counter means opposite. And the positive, or the negative angles go like a clock. So you can see, it's not blue on yours, I understand, but this angle is positive 135 because it's going counterclockwise. 210, it goes past 180 to 210. Past 90, past 180 to 300. Same thing, but the opposite direction. The opposite direction, right? Opposite direction, opposite direction. It's like if I could open my door the other way. I can't because of the door jamb, but if I could open it the other way and push it through, that would be a negative angle. One way is positive, and the other way is negative, right? But that's not the way doors work, okay? That's the difference. Okay, so today what we're gonna do, the big idea for today is how do we go between, I know what degrees are. Degrees, you guys have been using degrees probably since elementary school, right? Now we're gonna kind of switch it on you to go to radians, okay? So there's two formulas on how to switch. When do we know when to use one formula and not the other? Well, it depends on what the question is saying. If the question is asking for radians, you use the first formula. If the question is asking for degrees, you use the second formula. Simple as that. Just what are they asking? Are they asking for radians or are they asking for degrees? What is the question asking? Okay? So let's look at example number, it's supposed to be example number 1. I don't know why it's example number 4. So change that. That should say example number 1, A and B. Okay. So we have 85 degrees. That angle is 80 degrees. What would it be in radians? So the question is asking for radians, right? So that's where our question mark is going to be. Our question mark is going to be in radians. So that means we're going to use the first formula. Okay? So the first formula says radians equals degrees times pi over 180. Okay. I don't know what radians are. I know what degrees are, 80. So that's why I'm using this one. So for this guy, it's 80 degrees times pi over 180. And why is it pi over 180? You'll figure, we'll talk about that later. Why is it pi? Where do they get pi and 180? We'll talk about that later. Okay, so now we got to multiply. You guys did this on the quiz yesterday, and probably the quiz before that, and the quiz before. How do I multiply one fraction with one whole number? What's the first step that I got to do? Not flip it. If I was dividing, I'd flip it. You're right. If I was dividing. I'm just multiplying. So how do we multiply fractions, in other words? Straight across, right? Straight across. So you give both of them a fraction, and you measure, and you multiply straight across. So I multiply straight across. I get 80 degrees times pi is just 80 degrees times pi. Let me move this down here, actually. I'm going to run out of space quickly. On the bottom, 1 times 180 degrees. Well, 1 times anything just stays the same. Now you're going to do two things. You're going to see if I can cancel anything out, cross anything out, and you're going to see if you can reduce anything. Okay, let's start with crossing anything out. Is there anything on top and bottom that are the same? Degrees, right? Degrees divided by degrees, cancel out. No more degrees. Now 180 divided by, 80 divided by 180. Go to your calculators. What is 80 divided by 180 reduced? Your calculator does a great job of reducing fractions. 4 over 9, right? If you go 80 divided by 180, I think the biggest number is 20. So you would get 4 over 9. You can try it. Try it. 80 divided by 180. See if you get 4 over 9. So now we have 4 pi on top. 4 times pi on top. Over 9 on the bottom. It's reduced. You can't cancel anything out. That's how we know we're done. So the big idea here is 80 degrees is exactly the same as 4 pi over 9. So from now on, they're not going to say 80 degrees. They're going to say 4 pi over 9. And you're going to be like, what's that? What's 80 degrees? Okay. All right, let's do it for 125 now. 125. 125 degrees. What is 125 degrees? Well, we still want radians, right? That's still the question mark. Still the same thing, so we're going to use the top formula again. So we're going to say degrees times pi over 180 degrees. What does that equal? So multiply straight across. You get 125 pi, or degrees times pi, and then on bottom you get 180 degrees, right? Look for things that cross out, look for things that reduce. So what crosses out? What can we get rid of? Degrees. We don't want degrees anymore. We want radians. Okay? Now 125 over 80, go to your calculator. It's 25 over 36, right? 125, I think you can divide them both by 5. I think 5 is the number. So that becomes 25, this becomes 36. So we get 25 pi over 36. So 125 degrees is the same as 25 pi over 36. They're exactly the same. It's like 0 degrees Celsius and 32 degrees Fahrenheit. They're exactly the same. It's like, here's $1 and here's $1's worth of euros, or here's $1 worth of pounds, or whatever different countries use, right? It's the same thing, worth the same value. Okay? All right, so now let's go in the opposite direction. Now let's go the opposite. So this should be example number 2, 3, and 4. So now they give us radians. They say, hey, here's the radians. It's 13 pi over 12. What is the degrees? So now degrees is the question mark. So we're going to use the bottom. Degrees equals radians times 180 degrees over pi. Well, we don't know degrees. That's why we're using this formula. I'm not using the other formula. So, but they tell me radians. The radians is 13 pi over 12. Okay. All right. Multiply straight across. What's 13 times 180? It's 2,000 and something. 2,340. We still have degrees, and I still have a pi. And on bottom, you get 12 times pi, which is just 12 pi. Look for things to cancel out. Look for things to reduce. What can I cancel out? Pi, right? Pi on top, pi on bottom. I got to keep the degrees because I only have 1 on top. Anything divided by itself just makes 1. So pi divided by pi is just 1. Now I still have degrees. So what's 2,340 divided by 12? Should be a whole number. Is it 195? 195, yeah. So now 13 pi over 4 is the same as 195. 195 degrees, which is a little more than a half rotation, is the same as 13 pi over 12. All right? All right, so do number 3 now. Do number 3. Tell me what is 12 pi over 3. What's the conversion? What is 2 pi over 3? Sorry, 2 pi over 3. So we use the bottom again because we want to know what degrees is. That's the question. The question is asking about degrees. So we use radians times 180 degrees divided by pi. So 2 pi over 3. 2 pi over 3. So we multiply straight across, and I get 360 degrees pi. And on bottom, I get 3 pi. Okay. Look for things to cancel, look for things to reduce. What can I cancel out? Pi's. Pi's cancel out. They don't cancel, they just divide to be positive 1. Then I get 360 degrees divided by 3. What is that? 120 degrees. So 2 pi over 3 is the same thing as 20 degrees, 120 degrees. They're the same thing. Okay. Last one, so this is how it's going to work. We're going to do this is the last one we're going to do together. The one that says unit circle, it's got some blanks in it. This is your exit ticket. You guys are going to fill in the blanks. Half of the blanks are filled in, the other half are blank. So you're going to fill it in, okay? So this is the last one we'll do together, and then I'll show you how to do the exit ticket, okay? So convert -3 radians to degrees. So where's our question mark? Radians or degrees? Do we have a question mark for radians? Is that what they're asking us? Or are they asking us about degrees? Degrees, right? So it's just like the one we just did. What's missing from the radians though? What's missing? Usually we have this with radians. What's missing from the radians? Pi, yeah, there's no pi there. Sometimes that happens. It's okay. Sometimes that happens. So degrees, that's our question mark, equals -3 times 180 over pi. Because they said -3 radians. All right. Okay, so -3, we need to make a fraction because we didn't have a fraction before. Multiply straight across. What is -3 times 180? -540 degrees over 1 pi, right? Which is just pi. This one says round. This one is the only one that has said round. So we got it. That means decimal. So go to your calculator. Look for the pi button. It's right by the 9, right above the 9. And the it's right by the tangent button. It's right kind of above the 9. Okay? So what do you get when you go -540 divided by pi? There you go, -171 and change. This number right here. Round to the nearest tenth. Well, this 8 is the 10th. Right? That 8 is the 10th. So that 8 either got to stay or go up. Well, the 8 to the right says go up. So it's going to be 171, -171.9 degrees. So when radians doesn't have a pi, it's usually going to be a decimal. That's why it's a decimal. Okay? If it does have a pi, it's not going to be a decimal. All right, so let's look at the exit ticket down here. Let's look at, so next week we're going to start on something called the unit circle. That's the unit circle. So today I'm going to have you fill in some missing spots that are going to help you. So I'm going to show you how to read the unit circle, how to read it. It's a circle, and then you kind of see a graph, right? You kind of see a graph. So I'm going to show you how to use it. Okay, so first thing, where do we start on the unit circle? You always start at 0. You always start at 0. Make sense? And then you have, here's your y-axis. Here's your x-axis. Okay? A graph has 4 quadrants, 4 sections. So this guy is quadrant 1. We call it quadrant 1. Anything in this quadrant, anything in that 90 degrees is quadrant 1. And then we have quadrant 2, quadrant 3, and then quadrant 4. Okay? So you see circles and squares, circles and squares. And you only see positives because we're only doing positives today. So as you go, so watch the screen, watch my screen. As you go, so I'm going opposite of a clock, counterclockwise, and I'm hitting all of the circles, right? Are they going up or are they going down? Up, right? They're getting bigger, positive, right? If I wanted negative, I'd go in this direction. We're not doing negative today, though. Don't have to worry about negative. We're only going in positive. So what I want you to do is fill in two things. All of the missing circles. So anything that's missing, that one, that one, that one, those missing circles, and the missing squares. So I actually did half of them for you. The ones that are filled in are half. You have to figure out the other half. I'll do one with you guys. Actually, I'll do two. I'll do one of them. I'll pick one, and then I'll let you guys pick one. I'm going to do the first one, 0 pi, or 0 degrees. I have to figure out what this equals, radians. So my question mark is on radians. So this is the formula I'm going to use. If I'm looking for a radians, this is the formula I'm going to use. Okay? So let's go down here. 0 degrees times 180 over pi over 180. Because I'm trying to find radians. What is 0 degrees as a radian? Okay, we'll make it a fraction. Multiply straight across. 0 degrees times pi is 0 degrees times pi over 180 degrees. Look for things that cancel out. Look for things that simplify. Degrees crosses out. So now I got 0 divided by 180. Well, what is 0? Go to your calculator. Ask your calculator, what's 0 divided by 180? 0. So that means I have 0 pi. So 0 degrees is the same as 0 pi. Okay? So you're going to do that for all of the squares, and then you're going to use this guy for all of the circles. That's why I circled and squared it, because it shows you which one you're going to use. So you're going to fill them all in. I'll do one more with you guys if you give me one. Give me one you want me to do. I don't care, box or square, box or circle, I don't care which one. Pick one, and I'll do it with you guys if you want me to. If not, if you know what you're doing, go for it. If you're still not sure, give me one and I'll do it with you. Any of them you want me to do?
The next one right above it.
Next one, 30? Sure. We're looking for an empty box. That means I need a radians. So I'm going to use this guy here. So 30 degrees times pi over 180. Okay. Turn 30 into a fraction. Multiply straight across. 30 degrees times pi, 180 degrees. Look for things that cancel out. Look for things that reduce. Degrees reduces. Go to your calculator. What's 30 over 180? 1 over 6, right? 1 over 6. 1 pi over 6. Well, 1 pi, if it's just 1, we don't have to write that 1, right? So it's pi over 6. So 30 degrees is the same as 1 pi over 6. So for all the squares, that's what you're going to do. You're going to use your calculator to figure out, they're all going to have a pi in them. Most of them are going to be fractions. And then, if I want to find a circle, I'm going to use the other equation, or the other formula, because I want degrees instead. Okay? There are patterns to this. I'm going to tell you right now, there are patterns. So you don't necessarily need to do the calculations for every single one. If you see the pattern, use it. Use the pattern. You're like, oh, every time it goes by this, or every square does this, or every time I go a circle, it does this. Great. That's okay. That's a pattern. Patterns save you time, so you don't have to keep doing the same thing over. Okay? So that's what I want you to do. So you have 2 things I want you to do. Finish that. Every circle, every square, I want filled in. Okay? You got plenty of time. We got 20, almost 30 minutes. Okay? So you got plenty of time. Once you do that, then you can tape it in your notes. If you're stuck, I can't get this one, I can't get this one, I can't get this one, come on up here, I'll help you. I'm not going to give you the answer, but I will definitely help you. Okay?